Hello dear students, in this video we are going to discuss about the Faraday's law. First we will discuss about the process of electrolysis, what is an electrolytic cell and what is the meaning of electrolysis, and then we will discuss about the Faraday's law of electrolysis. Okay. Apart from that we will also discuss a few questions, simple questions related to simple numerical type of questions related to the Faraday's law. Okay. So first we will discuss what is an electrolytic cell. What is an electrolytic cell? So basically an electrolytic cell is a device that converts electrical energy to chemical energy. So an electrolytic cell is basically a device that converts electrical energy to chemical energy. That means it uses the electrical energy to carry out it uses the electrical energy to carry out a non-spontaneous redox reaction, redox reaction. Like for example, suppose we have molten NaCl. Now molten NaCl cannot decompose to sodium and chlorine by itself. Molten NaCl cannot decompose to sodium and chlorine by itself. But if we pass electricity through this molten NaCl, that is called electrolysis, that is the passage of electricity. So the simple idea is that NaCl in the molten state, suppose we are taking NaCl, this is obviously the molten NaCl. So molten NaCl cannot undergo decomposition by itself. It is not a spontaneous process. But if we do the electrolysis of molten NaCl, that is we pass electricity through this molten NaCl, then it gets decomposed to sodium and chlorine gas. So this process can be carried out only by the passage of electricity. That it cannot happen by itself. It is a non-spontaneous process, but it can occur if we pass electricity through this molten NaCl solution. So that is called electrolysis. Okay, so electrolytic cell is a device that simply converts electrical energy to chemical energy. It uses the electrical energy or the electricity to carry out a non-spontaneous redox reaction. Like this, a decomposition of sodium chloride is a non-spontaneous redox reaction, but it can be carried out by passage of electricity or in this device called electrolytic cell. So how does an electrolytic cell looks like? So basic idea of an electrolytic cell is like this. It looks like a beaker. A simple idea we will take, let's draw it in the next page. So a simple idea of an electrolytic cell is like this: a beaker, and in this beaker there will be a solution. Okay, this will be a solution, let us suppose. Now this solution, this can be this solution can be in molten state. This is called basically electrolyte. This solution is called an electrolyte. It can be in molten state, or it can be aqueous. It can be aqueous solution. Okay, so basically in the beaker there is a solution. It can be a molten substance or aqueous solution of any substance. Then what is there? There are two rods which are dipped in this solution or in this electrolyte. In this electrolyte it is dipped. Two rods are dipped. Now these two rods are basically, so this was an electrolyte, and these two rods, these are basically known as electrodes. Now electrodes, they can be either inert like platinum, or they can be reactive like copper. So these electrodes, they can be either inert or they can be reactive. Okay, so like example, platinum electrodes, most of the time when we take platinum electrode, that means the electrodes are not taking part in any kind of reaction. But if we are taking copper electrode, so it can also take part in reaction. That is why we say that copper is the reactive electrode and platinum is the inert electrode. Next, these two electrodes, they are connected to a power source, or we can say a cell or a combination of cells. This can be connected to a single cell or a combination of cells. Okay, so obviously the rod which is on the left hand side, this becomes positively charged because it is connected to the positive terminal of the battery, and it becomes the other one on the right hand side, it is negatively charged because it is connected to the negative part of the battery. Okay, so the rod on the left hand side is basically the anode. Why anode? Because on this rod oxidation will take place. On this rod oxidation will take place, and on the right hand side, that is called cathode. Why? Because on this the reduction will take place. Okay, so this is a setup. This is the setup which is called an electrolytic cell. So this setup is basically known as, or it is called an electrolytic cell. Okay, now so this setup is called an electrolytic cell. So it has a few components. First one is the electrolyte, that can be in molten state or aqua solution. The two rods which are called electrodes. The one on the left hand side is anode, that is positively charged, and oxidation takes place at anode. The one on the right hand side is the cathode, that is negatively charged, and the reduction takes place at the cathode. Okay, so these are the components of an electrolytic cell. Now when we pass electricity, when electricity is passed through this electrolytic solution, the process is called as electrolysis. Okay, so when electricity is passed through the electrolyte, that can be either molten or aqueous, the process is called electrolysis. Fine. So this is about the electrolytic cell. Now suppose we take the example of molten NaCl. Just I took that example. So we have molten NaCl. This is molten NaCl. So when electricity is passed through this molten NaCl, what happens is, so this was the molten NaCl. When electricity is passed through it, it decomposes to sodium and chlorine gas. And this sodium gas, sodium metal. Now sodium is also usually in the molten form. The sodium which is formed, that is also usually in the molten form, but it can be solid also. That depends. Okay, so whatever it is, so we get sodium and chlorine. Now sodium, it is usually formed at the cathode. Okay, sodium is usually formed at the cathode, that is the negative electrode, right hand side. Okay, so sodium is formed at the cathode. I will write it down. Sodium is formed at the cathode and chlorine at the anode, right? So this is the case. Okay, now we will also learn why it happens like this, sodium at cathode, chlorine at anode. That will also be discussed by us in the coming videos, but right now we are not going to discuss about that. So first, just have a clear idea about what is an electrolytic cell and what kind of process occurs in the electrolytic cell, or what is the use of electrolytic cell. Okay, now when molten NaCl is electrolyzed, sodium is formed at cathode and chlorine at anode. Now what is the amount of these two formed at different electrodes? Now these amount of the substances that is formed at different electrodes, this amount can be determined using the Faraday's law. So the amount of substance is determined by Faraday's law. So what is the basic idea behind the Faraday's law? So Faraday's law is useful for determining the amount of substance formed at different electrodes. So it helps. So Faraday's law helps to determine the amount of substances formed at electrodes during the electrolysis. So this is the use of Faraday's law. Now there are two laws of Faraday's. So Faraday's law, we will now come to the discussion of Faraday's law. Now there are two laws. Faraday has two laws. Faraday's law. So first law and second law. So we will begin with the Faraday's first law. Okay. So now next we are going to discuss about the Faraday's first law of electrolysis. Faraday's first law. Now in CBSE, they directly sometimes they ask this to state the law. Okay, so that is why you need to remember the statement also. For CBSE point of view, you need to remember the statement also, because they directly ask the statement also. Sometimes they state the directly question comes like state the Faraday's first law of electrolysis or state the Faraday's second law of electrolysis. So for that you have to remember the statement. So so according to the Faraday's first law, the mass of substance in grams, usually we take the mass in grams only. So that is why the mass of substance in grams formed at an electrode is directly proportional to the quantity of electricity passing through the electrolyte. So this is the statement of Faraday's first law. Okay, the mass of substance which will be taken in grams formed at an electrode is directly proportional to the quantity of electricity passing through the electrolyte. Now what is the quantity of electricity? That means the total charge. Remember, the quantity of electricity means the total charge. So you can also replace this quantity of electricity with the total charge passing through the electrolyte. So quantity of electricity is simply the total charge that passes through the electrolyte. So if W is the mass of substance formed at electrodes, obviously in grams, and Q is the quantity of electricity passing through electrolyte. So if this is the case, that W is the mass of substance formed at an electrode and Q is the quantity of electricity or charge that is passing through the electrolyte. Now charge will be obviously in coulombs. So in that case, W is going to be directly proportional to Q, and when we write an equal between them, then W will be there comes a constant, that is Z. Now this Z is called electrochemical. This is a proportionality constant called electrochemical equivalent. Electrochemical equivalent. Now also you must know this, that Q is equal to Q, that is in coulombs, is equal to current in amperes into time in second. You must know this, that Q is the charge in coulombs. I am writing it completely. So Q is the charge in coulombs, I is the current in ampere, and T is the time in seconds. Okay, so Q is, that is Q charge is equal to current into time. The units also you need to remember. So that is why, so we can write, so W is equal to ZQ can also be written as ZIT, right? Now sometimes you may be asked about what is electrochemical equivalent, that is also called ECE. The electrochemical equivalent is also called ECE in short. So how to define this electrochemical equivalent, right? So for defining that, we can write, if, so we can take one case, like if Q is equal to 1 coulomb, that is the total charge, total quantity of electricity that passing through the electrolyte is 1 coulomb, and current is, or out of the two anything can happen, current is 1 ampere for time 1 second. So either we can take charge to be 1 coulomb or current to be 1 ampere for time 1 second. Okay, so in both the cases Z will be equal to W. So that we can say that electrochemical equivalent, that is ECE. So ECE, that is electrochemical equivalent, is the quantity of or amount of substance, is the amount of substance formed at electrodes when 1 coulomb electricity passes through electrolyte. Or we can say, or 1 ampere current passes through electrolyte for 1 second. Okay, so this is how we can also define the electrochemical equivalent, that is Z, right? So Faraday's law, mass of amount of substance formed at electrode directly proportional to quantity of electricity passing through the electrolyte. When we write equal, we get a constant Z, that is also called electrochemical equivalent. Now current can be written as charge into time, charge can be written as current into time, Q is equal to IT. So from there we can write Q as IT. So we get W equal to ZQ or ZIT. Now from here, to define Z, that is electrochemical equivalent, we take a case where charge is 1 coulomb. Either we can say that charge passing through the electrolyte is 1 coulomb, or we can say that current passing through the electrolyte is 1 ampere for 1 second. In both the cases, Z will be equal to the W. So from here we can define that electrochemical equivalent is the amount of substance formed at electrode when either 1 coulomb electricity passes through the electrolyte or 1 ampere current passes for 1 second. So this is how we can define electrochemical equivalent. Now how to determine the value of electrochemical equivalent? So now this is the definition. This is the definition that we can use to define electrochemical equivalent. But how to determine the value of electrochemical equivalent? So to determination of the value, determination of ECE, that is electrochemical equivalent. So we mean to determine the value of electrochemical, mathematical value, numerical value or mathematical value, whatever you can say. So how to determine the value of electrochemical equivalent? So how to find it? Now I could say straight away, I could say that the formula for electrochemical equivalent Z is E upon F, or we can say E upon 96500. Now F is basically 1 Faraday, that is equal to 96500 coulombs. Now E here is the equivalent mass. E here is the equivalent mass of substance that is getting deposited, obviously, and F is 1 Faraday, that is approximately 96500 coulombs. We can also get into the derivation, how to derive this value of Z. If you ask me the derivation, then I will upload a separate video for the derivation of Z, or how to determine the value of Z, but it is not required. So if you require, if you are willing to know it, I will definitely upload. Just you can request me, I will upload the video for a separate video for this determination of the value of Z. But you can just know this formula or know this expression, that Z is E by 96500. That will be sufficient for you. Okay, you don't need for the CBSE part. Now, so Z is E by 96500. So this is how you can calculate the value of Z, that is electrochemical equivalent, and you can just put it in this expression for W, and you can get the value of you can get the mass of substance formed at any electrode using this formula, W equal to ZQ or ZIT. Now, so this is all about the first law of electrolysis. Now coming to the second law of electrolysis, Faraday's second law. Faraday's second law of electrolysis. So what is the Faraday's second law of electrolysis? Now it basically says that when we have a certain number of electrolytic cells, like 2 or 3 electrolytic cells which are connected in series. Suppose we have an electrolytic cell, the first electrolytic cell like this, second one like this, and third one like this. So these 3 electrolytic cells, these are connected in series. Now what is the meaning of series connection? You must know that from the physics, that when different things or different devices are connected in series, that means the same charge or same current will pass through them. Okay, so these 3 cells, these 3 electrolytic cells, these are connected in series, but they have different electrolytes present in them. Okay, these 3 cells are electrolytic cells, these are connected in series. Now suppose the first one contains zinc sulfate, the second one contains copper sulfate, and the third one contains silver nitrate. So these 3 cells are connected in series. Now, okay, so now what the second law says is, when we have, I will write the statement first, then I will get into the mathematical expression, or how to write the mathematical expression for this. So it says that when a number of cells, like 2, 3, anything, number of electrolytic cells basically, when a number of electrolytic cells are connected in series, when a number of electrolytic cells are connected in series, and that is, we can say, same amount of electricity passes through them. Same amount of electricity passes through each of them, right? So when a number of electrolytic cells, 2, 3, 4, any number can be there, so they are connected in series, that is, we have same amount of electricity passing through them, then mass of substance formed at any electrode is directly proportional to its equivalent mass. Okay, so this is the statement of Faraday's second law, that when a number of electrolytes or electrolytic cells are connected in series, like suppose the first one having zinc sulfate, second one having copper sulfate, third one having silver nitrate, so these are the different electrolytic cells which are connected in series. Same amount of electricity is passing through them, each of them. So mass of substance formed at any of these electrodes, any of the electrodes of these cells, will be directly proportional to the equivalent mass of that substance. Okay, so equivalent mass means the equivalent mass of that substance. Like suppose in this first one, at this is positive negative, so at the cathode, obviously the negative electrode, zinc is going to get deposited. So here zinc is going to get deposited in the second one at cathode, copper is going to get deposited in the third one at cathode, silver is going to get deposited. So if W is the mass of substance formed at an electrode, at any electrode, if W is the mass of substance getting formed and E is the equivalent mass of that substance, E is the equivalent mass of that substance, then W should be directly proportional to E, or we can say W by E as constant. W should be directly proportional to E, or we can say W by E as constant. Okay, so this is the Faraday's second law. Check this was the statement, and this is the arrangement that we have to do. A few cells which are connected in series, each of them having some substance formed at different electrodes. So I am assuming only about the cathode. Out in these three cells at cathode, different metals are going to get deposited. In the cell number 1, suppose this is the cell number 1, zinc sulfate. In the cell number 1 at cathode, zinc is going to get formed. In the cell number 2 at cathode, copper is going to get formed. In the cell number 3 at cathode, silver is going to get formed. So in these three, the mass of substance that is going to get formed is W. If we take it to be W, if W is the mass of the substance going to get formed in these three, then the mass of the substance that is going to get formed will be directly proportional to its equivalent mass. So W is the mass of substance formed at electrode, and E is the equivalent mass of that substance. Okay, so W must be proportional to E, directly proportional to E. In that case, W by E will be constant. So this is the Faraday's second law. So for the above example that we have taken, for the above example, W mass of silver must be, let's say in the first one we have zinc, I think, so zinc, so mass of zinc by equivalent mass of zinc must be equal to mass of copper by equivalent mass of copper, that must be equal to mass of silver upon equivalent mass of silver. So this is the Faraday's second law when applied for the above example that we have taken. It will look like this. The expression will look like this. So remember, for the Faraday's second law, whenever some cells are connected in series, W by E for all the substances will be constant. Okay, W by E for all the substances will be constant, and that must be equal to now if you check, it is basically, we can, from the first law only we can say that W by E must be equal to what? So see, from the first law we know, from first law W equal to ZQ, we know that, and W is equal to, so Z can be written as E by F. F is 1 Faraday. So now if W by E is a constant, then it must be equal to Q by F, right? So that's it. So W by E must be equal to, we can also go further to say that W by E is a constant, so it must be equal to what? So it must be equal to Q by F. Okay, now Q is a, now that must be equal to, now in, if you see the case, same current is passing through all these, so Q is a constant, F is already a constant, F is basically 1 Faraday, so it is already a constant, and Q is also same for all these three because same current passes through them, same electricity, same amount of electricity. Okay, since all these are connected in series, these three are connected in series, so same amount of electricity is passing through all these three, right? Same amount of electricity, that means that those all three has same value of Q, all three has same value of Q. So and Q, F is already a constant, so Q by F will be a constant, and W by E must be equal to what? This constant is actually what? Q by F. Understood? So this much for this video. In the next video we will discuss about a few problems, numerical problems from NCERT. I will take some simple problems for NCERT, from NCERT to discuss from the Faraday's first law and second law, right? So this much for this video.